What is life cycle of powering computer? For a computer to start running, it needs to have an initial program to run. This initial program or bootstrap program tends to be simple.
Hey computer, wake up! You must start working now.
I'm ready now.
Typically, it's stored within the computer hardware in firmware. It initializes all aspects of the system, from CPU registers to device controllers to memory contents. The bootstrap program must know how to load the operating system and how to start executing that system. To accomplish this goal, the bootstrap program must locate the operating system kernel and load it into memory.
Let's generate a computer.
The kernel is a computer program at the core of a computer's operating system that has complete control over everything in the system. It is the portion of the operating system code that is always resident in memory and facilitates interactions between hardware and software components. So we say that the operating system is the one program running at all times on the computer, usually called kernel. Once the kernel is loaded and executing, it can start providing services to the system and its users. Some services are provided outside of the kernel by system programs that are loaded into memory at boot time to once this phase is complete. The system is fully booted and the system waits for some events to occur. When you turn on a computer, its memory is usually uninitialized, hence there is nothing to run. Early computers would have hardware that would enable the operator to press a button to load a sequence of bytes from banished card, a tape drive.
Now, I can work. Yay.
Since the operating system and its users share the hardware and software resources of the computer system, a properly designed operating system must ensure that an incorrect or malicious program can't cause other programs or the operating system itself to execute incorrectly. In order to ensure the proper execution of the system, we must be able to distinguish between the execution of operating system code and user-defined code. We need to separate modes of operation, user mode and kernel mode, also called supervisor mode, system mode, or privilege mode. A bit called the mode bit is added to the hardware of the computer to indicate the current mode, 0 for kernel or 1 for user. With the mode bit, we can distinguish between a task that is executed on behalf of the operating system and one that is executed on behalf of the user. The dual mode of operation provides us with the means for protecting the operating system from errant users and errant users from one another. When a user application in user mode requests a service from the operating system via a system call, the system must transition from user to kernel mode to fulfill the request. Whenever a trap or interrupt occurs, the hardware switches from user mode to kernel mode, that is, changes the state of the mode bit to 0. The system always switches to user mode by setting the mode bit to 1 before passing control to a user program. Each CPU core executes a single task at a time. However, multitasking allows each processor to switch between tasks that are being executed without having to wait for each task to finish. Preemption. In time-sharing systems, context switches are performed rapidly, which makes it seem like multiple processes are being executed simultaneously on the same processor. Depending on the operating system implementation, switches could be performed when tasks initiate and wait for completion of input-output operations, when a task voluntarily yields the CPU on hardware interrupts, and when the operating system scheduler decides that a process has expired its fair share of CPU time. Thank you.